So I chose the same problem as the assessment for my kinematics reassessment. Uh, at first, I didn't understand the question properly. I thought it was asking for the height right after the burn, which is the Y2. But after looking at the key, I realized that it was asking the height, how much further it went after the burn. So I found the Y2, which is 94.5 meters in the class, and then I didn't do anything further. So to find the maximum height, first I have to find the velocity of the Y2. I call it V2. I use this formula, which is delta V y equals acceleration of y times delta t. And velocity of y2 is 21 meters per second squared times 3 seconds, because when you add the initial y velocity to the to both sides, it doesn't do anything because it's 0. And after I found that, I had to find the velocity at y3, which is v3, and I know that it is equal to 0 because that is at the highest point and it's not going up or down for that instant. So we don't know the time from y2 to y3, so I used this equation, which is this, the delta v squared, which is final velocity squared minus initial velocity squared equals acceleration times delta x. And when you add the initial velocity to both sides, it becomes final velocity squared equals acceleration times delta x plus initial velocity squared. And when you replace them with the y components, it becomes v3 squared equals a acceleration of y2, because it is not a y1 acceleration, which is 21 meters per second squared. It is now negative 9.8 meters per second squared. Then times delta y, which is y3 minus y2, then plus the v2 squared. And while I was looking at the key, I couldn't understand why you took off the 2 times 2 from the equation, and I came up with my own understanding that it is because I am calculating only the half the trajectory of the rocket, not the whole trajectory. The half, which is from launching to hitting the ground. Now, and half the trajectory would be from the ground to the highest point. So when I rearrange the equation for y3, I subtracted the v2 squared to both sides, and then divide acceleration to both sides, and then add the y2 to both sides, and it became y3 equals negative v2 squared divided by acceleration of y2 plus y2, and it came out to be 499.5 meters at the maximum height. And when I plugged this number back into y3 and solved it for v3 squared, it equaled to be 0.